take their seat.
My name is Karen Weaver. I work for the Center for Transportation Studies at UVA. So I drove up here today, not with Jhony, but Jhony possibly about Charlottesville. This is a lunch and learn series that we're doing for the Virginia Transportation Research Council. And the goal is to share information and research from people working in the field. This one, we've done, trying to go around the state. This particular topic, let me just say that we have a remote audience of about 35 people, as far as I know. We have an in-person audience of about 8, I think is what we have at RTP. So I just wanted to tell you about the topic and the speaker. So this topic today is an overview of asphalt mixture, including design lab elements, field testing, and use of recycled materials in these mixtures. And then I want to say, I think that Jhony, you can either ask for questions if they come up, or you can hold them to the end. For the remote audience, it might be a little easier if you hold them for the end. We have an online facilitator who will be taking any questions from the remote audience if you want to put them in the chat, or if you want to unmute yourself and ask the questions when we're doing questions, that's fine as well. So our speaker today is Jhony Habbouche. He's a senior research scientist at VTRC. He specializes in all aspects of engineered paving materials, including advanced testing and characterization, evaluation, modeling, mechanistic analysis, and cost-benefit analysis. He is a member of the Association of Asphalt Paving Technologists. He chairs the communication committee there and is an associate editor for them. He's also a member of the American Society of Civil Engineers, the Highway Pavement Committee, the American Society of Testing Materials, and the Transportation Research Board. He's editor of the Transportation Research Board and a licensed professional engineer in Virginia. He received his PhD in civil and environmental engineering from the University of Nevada, Reno, and he won multiple outstanding international graduate student awards. So welcome, John. Thank you.
Yes, I want to do a sound check and a picture check. Can you hear me online?
Yes, we can.
Can you see the presentation?
Yes, we do.
Perfect, thank you. Well, good afternoon, everybody. I know it's going to be a little bit weird while you're enjoying your lunch. It's supposed to be a little bit calm. You'll be hearing me talking about something you may like, asphalt. I'm not sure in terms of audience who has an asphalt background, who does not, but I'll try to be simple, practical, straightforward, up to the point, and not too much technical. So thank you, Karen, for the introduction. That's so nice of you. So today we're going to talk a little bit about paving the way for sustainable asphalt mixtures. Material recycling. So recycling is the main component on how we can address that in a sustainable manner while still improving performance of our asphalt mixture and make sure that we have good performing roads outside. So let's see. This is not.
That doesn't, we're clicking the touchpad on here.
Now it's working. So if you do not have a background on asphalt mixtures are being used on highways. They could be used on airfields, for airports, port facilities, parking lots, some recreational areas like bikeways, tennis courts, tracks, and so on, hydraulic structures. Our focus today, as you may notice, is highways. For those who do not know, the component is going to be the asphalt binder, which comes from the crude oil source that gets separated, and then we have the light molecules that go up to the top. Usually these are the most expensive particles. They go into like kerosene for the planes. That's why when you buy a plane ticket, it's more expensive than when you go in a bus, etc. And then at the bottom, you have that residual product that gets worked on, and that's what constitutes the asphalt binder. We get the aggregate, we have the air void. So when we put these together, they have kind of air void pockets in between. And then in some cases, we add modifiers or additives, whether they are polymers, fibers. Today, we're going to focus a little bit on recycled plastics, how we can repurpose plastic waste into a good performing polymers for asphalt mixture, and then ground tire rubber, also another case study. So if we're not aware, Virginia's network has around 129,000 lane line, and that's the third largest public roadway network in the United States. That's very important. And that's why we give a lot of importance for pavement in general and asphalt mixtures in particular, because 98% of the surface that goes on these roads is really asphalt. So we really care about developing a good performing asphalt, longer lasting asphalt, as well as an asphalt that fits some of the sustainability and resilience concepts that we start looking more into details into these concepts. So as a research council, which we are the right arm of the Virginia Department of Transportation, we do research and we try to help them, endorse innovation and try to have a more cost-effective, better performing mixes and so on. We do support from 4 different perspectives. We have the materials, and that's going to be the focus of today's presentation. We do have the paving design. We have construction and maintenance. When we talk in terms of materials, some of you may have heard of some of the initiatives that we worked on. For example, the high polymer multi-cut mixes. And usually this is typically used majorly in Northern Virginia, Richmond, and Hampton Roads. The stone matrix asphalt, that's a typical mix that VDOT adopts or uses throughout the entire Commonwealth. Recently, we started adopting, or we're shifting towards the full implementation or adoption of the balanced mix design. That's when we do our mix design, not only based on recipe, but also based on performance. And we're trying to improve the performance of the mix to be laid down or placed on all the roads. And then also we use that frameworks to evaluate additives and other alternatives like the use of rejuvenators, recycling agent, other stuff like rubber or hybrid rubber, and recycled plastic and plastic waste. So when we talk about sustainability, I want to take a minute and define that from a pavement perspective. We're looking at the economic factors. So we want to make sure that we have something that is cost effective, that's within the budget. And because we're given a certain amount of budget of money, we want to make sure we take care of as many lane miles as we could within that budget. And we make sure that we have a very good and optimized prioritization process. Second one is environmental. That's very important. We want to make sure that we're cutting down on the CO2 emission and the gas emissions from there. And we'll make sure we're having optimized use of the energy when producing asphalt mixture. And then the third one is a social. We want to make sure that we're meeting human needs such as health, safety, equity, employment, comfort, and happiness. Simple example, if you're driving like me on I-64, there was a lot, around maybe 10-15 minutes delay because of the small incident. So we want to make sure to avoid these while doing our pavement during construction of these pavements. So I'm going to talk about reclaimed asphalt pavement, or what's known to be a RAP. And that's when you go and you mill your existing pavement and then you bring it to the plant and then you create a stockpile of that RAP material. So usually this is owned by the asphalt producer. We estimate around 10 million tons statewide. That's a lot. So if you try to go and just have a layer of 100% RAP mix, it does to you around 8,400 lane miles. That's a lot. So that's a lot of RAP. So we start looking at, okay, how we can make use of the RAP and be included into the existing mix design. So the mix design initially started to be only virgin aggregate, virgin asphalt binder mixed together, then you get a mix. So now we're going to add a third component, which is the RAP material. We're going to talk a little bit about that in the first portion of the presentation. So VDOT spec, as of today, they allow up to 30% RAP, unmodified dense graded surface mixes. So the surface mixes will have 30% of them RAP. In base course, that goes up to 35% RAP. In stone matrix asphalt mixture or the gap graded mixture, they allow up to 20%. That's with the PG70 minus 22. And then when we go into interstates, when we start using polymer modified, we still limit this to 15% just to have a better control on the stiffness. And we do not want to dilute the amount of polymer being used in the asphalt binder. So that's VDOT specification. So now we're trying to take the first bullet, the 30% RAP, try to push the envelope a little bit. Can we increase that 30% to 35, 40, 45, maybe up to 60%, while still producing a very good performing mix, short-term and long-term, in the lab, in the field, as well as taking into consideration the capabilities of the plant, the asphalt plant out there, because not all plants can go up to 45, 50% RAP. So motivation to using more RAP, again, environmental impacts, because we're kind of recycling, cost reduction. So a portion of your mix is already material that's available for you. And then industry factors, that's very important because also asphalt contractors, sorry about that. Because asphalt contractors have limited space for storing the wrap, so they want to make sure that they use it into their mixes. In terms of VDOT stance, we encourage material recycling and reclaiming while keeping in mind that we need a good performing mix and a longer lasting mix. We don't want to do it just to do it. Cost reduction measures, and we encourage innovation because with the use of high wrap, you allow the use of some innovative material like recycling agent, rejuvenators, and other, all under an engineered framework. And then at the end, and that's very important, ensure quality materials and performance. So performance comes first. We do not want to do recycling just to help with recycling, but also jeopardize performance. So we want to tackle those in a very engineered manner. So challenges of high wrap mixes, they can be difficult to produce. Again, not all contractors have the capabilities to do that. Wrap properties, the wrap stockpile is one of the components that is the most varying during production. So wrap stockpile, a portion of it today is going to be different tomorrow, going to be different after tomorrow. The properties will change throughout the production. So we're going to have a good handle on that. Maintaining consistency during production. Again, we talked about the control and management of wrap stockpile. And then meeting volumetric and performance acceptance criteria. We will be able to have a good recipe, but still meet performance. Just to simplify it, I always like to give that example. When you bake a cake, you may have the perfect recipe that gives you the best cake looking, fluffiness, and everything, but the cake may taste awful. So the recipe or volumetrics are having the best recipe, taking off or a bad performance. So we're trying to have both a good recipe as well as a good taste, good performance. So again, we talked about VDOT back in 2007. They started allowing higher percent wrap up to 30%. So we used not to allow that, then we started introducing wrap at a lower percentage, and now we hit the caps 30%. And then in 2013, some of the sections were built with 45% wrap. These sections are doing fine as of now. Then we started introducing some ways of dealing with the wrap. And then in 2017, 2018, we introduced that engineered framework on how we can design a good recipe of high wrap mixes with good projected or prospective performance. So in 2019 up to 2022, we had a lot of field trials in several districts. Unfortunately, we haven't had one in Stanton yet. We're looking forward to maybe some in the near future. And that's under what probably you've heard about balanced mix design. We've been talking about that concept a while. So when we look at a high wrap, we're gonna look at it from a recipe point of view, as well as a performance. We did some field trials, we did pilot project. And then if you're not aware, VDOT has a program that does accelerated pavement testing through heavy vehicle simulator. And that's when you do fast testing on some lanes. This is located at Virginia Tech down in Blacksburg. It's operated by them, but it's a VDOT program. And then we do have some lanes there as well, so we don't have to wait 8 or 10 or 12 years to make a decision on whether they're going to work for us or not. We can get that in an accelerated manner in a matter of a year or two. So if you're not familiar with Virginia's balanced mix design specification, so we target several primary distresses that are of interest for us and that are concerning to us. Cracking, we've all driven on, so for example, I-64, and you see sometimes cracking around the area of the wheels, the car wheels. So we use what we call an indirect tensile cracking test, or IDCT. Probably you've done some of that testing in your labs if you're in the asphalt mixture domain. And then we look for the cracking tolerance index, what we call CT index, the minimum value of 70. So we project to have a good performing mix if it has a CT index of 70 and above. While for the rutting, we use the asphalt pavement analyzer. That's another test that simulates having the wheels of the truck on top of the asphalt at a high temperature, 64 degrees C. You can imagine like a hot summer at an intersection where you have all your traffic, heavy traffic stopping, then accelerating, then that creates rutting, these longitudinal depression. So we have a rut depth of a maximum of 8 millimeter. We also look at the durability. That's the Cantabro mass loss test, maximum 7.5%. And we want to make sure that we're not jeopardizing moisture damage. That's also critical for Virginia. We look at a tensile strength ratio a minimum of 80%. That's typical, that hasn't been changed since a while for Virginia. So that's our framework. It balances, you see the middle balances between cracking and rutting, giving you a good recipe, good performance mix, good performing mix. So the high-rep trial that we've done from 2019 through 2023, there are many, there's a lot. So we've done some up in Nova, July 2019, then we've done some in Leesburg, July 2020. We've done some in Leesburg and Nova, then we've done some in Fredericksburg. In August 2020, we're gonna take a look at some of these data. We went down to Richmond, we've done some in Colony Brookfield in August 2020. And then in 2021, we've done some in Nova, and then again last year, we've done some in Nova as well. So we're gonna take an example and then see our typical mixes compared to these engineered mixes that have a little bit more wrap. So you see we're comparing 30% wrap to 40%. But for us to be able to address that high wrap that needs more stiffness, in one case we use what we call recycling agent to help, soften the mix, make it more workable, better compactable. And then the second one, instead of using a 64S minus 22, that's our typical binder grade, we bumped it down to 58 minus 28. So we talked about our framework that we're looking at cracking, running, and we're looking at the mass loss, the durability. So we're looking here at the mass loss durability. So the first mix is our typical mix, the B1, that's our control. The second mix, B2, is a 40% wrap with recycling agent, and the third one is a 40% wrap with softer binder. So you're gonna see three types of bar. You have the dark blue, you have the light blue, and then you have the shaded blue. So the dark blue is what comes during the mix design. And you see that your mass loss decreased for the 40% wrap B2 and B3. That tells me that these mixes will have a similar or better durability than the control mix because they are engineered, that's expected. We've seen a similar observation at the plant. So that's the light blue in the middle. So these samples we took right away at the plant, we compacted, and then we tested that. And then you have the shaded blue, the third one, we collect mixtures and then we take them into our lab and then we do some extensive more testing there. And then we've seen that we had similar observations. It's a similar durability or better durability. So the lower the value, the better is the performing mix. That tells us durability wise, we put a little bit recycling, but we didn't, jeopardize durability in that case. So we're good in terms of that. So again, we're looking at durability, cracking, and rutting. The second one will be rutting. So it's the same story. We did the APA rut depths. The lower the rut depths, the better the mix is in terms of resistance to rutting. So we look at the dark blue, you will see that the mixes are similar or better in terms of resistance to rutting. The same thing was at the plant, which are the light blue in the middle. And then the same thing happened with the shaded blue, the third one, as well as reheat. So we're good also in terms of rutting. So now we check the box in terms of durability, check the box in terms of rutting, we're ready to move. The third one, which is usually the most critical for Virginia, which is cracking, and that's the hardest to deal with. So we do the cracking tolerance CT index value. So the higher the value, the better is your mix in terms of resistance to cracking. So you'll see that with the design, your control had a very low value, even not meeting the spec, while the others had much higher values. That means these mixes are expected to be better in terms of resistance to cracking. And then we had kind of a similar trend, whether at the plant or the reheat. So now we check the three boxes, durability, cracking, and rutting, that these mixes are expected to have similar or better properties at the short term. So again, we haven't put these in the field. I mean, they were placed in the field, it's still early performance. Again, at the end of the day, the true performance that we get is what the field gives us, but also we don't have to wait 8 to 10 years, 12 years to make a decision because we would have missed the train by then. So we need to find kind of these engineered tools to put us on the right track so we can make some, starting decisions and then modify as needed when we get more good performance. So this is one of the projects that happened on Riverside Parkway up in Leesburg in Nova. That's last year. So we've had a full contract on that, around 2,000-ish tons. You will see that's a 40%, that's a 45% mix. That's beautiful laid. You can see that on the left side. You can see the people In the middle picture, that's during the paving operation. There were no changes in terms of practices when it comes to paving operation. And then that third one, people didn't have any hard time working around that mix. So that mix had a high rep, but had also the chemical component, the recycling agent, which you see that product in green, added to it just to make sure that addresses the stiffness. Is the more recycled material, that's a wrap, aged, stiff material. It loosen it a little bit, soften it a little bit, make it perform better, and workability-wise, compactability-wise, it's better as well. Just looking at some of the data, you see that here we're comparing it to the design. The values are all above the 70. That's the threshold that we talked about. Whether we are doing on-site, or we're doing in the lab. So the on-site are the green ones, and then the blue ones are in the lab. So we're projecting good performance. So in the 2022, we were at a level where we do not need a control. We're just doing the field trial and monitoring it by itself. I want to talk a little bit about our heavy vehicle simulator, HVS. So you see that picture on the top right and bottom right. You see that whole thing. You see that HVS, the orange one. So you will have a 100 feet. A 100-foot lane, and it's a 12-foot width, and then actually it is 300 feet by 12 foot, and then you have that machine run into it. It's like a wheel, fast wheel that goes down on the lane, then back up, then goes down, then back up. It does testing at 40 degrees C. That's what we call accelerated testing, and that helps us to get a quicker idea of how these mix gonna perform in the field. That for sure, taking these measurements and these conditions and putting them into the reality of real life in the field, gonna take some modeling and some comprehensive analysis, which we're not gonna talk about it here. But I wanna let you know that we're doing some of these trials into that HVS. If you get a chance, if you're at VTech one day, then we're located right next to the Smart Roads. Very nice program, very nice apparatus. And then we use it as a tool to validate some of the findings that we have. So we have 6 lanes. We have the typical mixture 30%, but we do have 4 mixtures that have 45%. We even made it up to 60%. And we use several alternatives, whether we use some chemical additives, engineered chemical additives that we call the RA, or we use a softer binder, that's the 4th bullet, or we use both together when we get the 60% wrap. We're currently doing the testing. We're expecting the findings of the study to be out by end of October in 3 months. But I wanted to tell you that we have that nice school program that helps a lot in terms of research as well as practice. So finding a conclusion from this portion is we can push a little bit recycling when it comes to asphalt. We can include more RAB as long as it's designed and produced properly following an engineered framework. So we'll have a good recipe as well as we'll have equal or better performance. One thing we're looking at is we're trying to project that performance on the long term, 8 years down the road, 12 years down the road. We're currently working on that just to make sure that we're not being blindsided. We're getting something that's good at the early age, but then that thing is getting worse or the rate at which it is being reduced in terms of performance is being maybe faster than the usual. So we're making sure that we're addressing that carefully before we start doing more and more out in the field. So some lessons learned, again, control of RAB stockpile, that's for a contractor. It's very important. Consistency is the key. That's very hard when it comes to RAB stockpile, but we're blessed to have very good contractors and asphalt producers who know very well how to take care of their RAB material. We do have a lot of publication on that topic if you visit the BTRC website. And I'm not sure if they're going to share the presentation with you, but you will see some of the titles. You can pull out the report and read. They're written in a very practical manner that do not require, you're going to enjoy it. It's not going to be boring. So I'm going to switch gears a little bit. We talked about the typical thing, including RAB material and asphalt mixture. But recently we started an initiative into looking about how we're going to include or repurpose plastic waste, recycle plastic, and put it into asphalt mixture. I mean, a portion of the lunch here has like plastic bottles, like plastic boards, things like that. How these can be repurposed. The polymer constituting that plastic can be included into asphalt and then can be taking advantage of it in terms of positive advantage. Some of these polymers are good, and then they help enhancing the performance of plastic. If you're not aware, as of 2017, around 35 million tons of plastic in the US, only 8% of them were recycled and repurposed. You have 60%, they're undergoing combustion, and that's not good for the nature. Then you have 76% that are stacked in landfill, whether thrown into mountains and piles of plastic or thrown in the ocean. And you probably have heard about a lot of people trying to figure out how they're going to save the fish, what they're going to do with the plastic. So we're looking into several homes how we can repurpose the plastic. One of them is the asphalt. However, we're going to keep in mind that we're going to do that in an engineered manner. So engineering is a big component. In an economic manner, that's going to cost me more than the usual. I'm going to allocate budget for that. So that's very important. And the environmental benefits. We want to make sure that we do not, for example, cut down on the plastic, but I'm generating many microplastics by putting them on the road once it rains. And then everything goes, you have the wear up with the tires, everything goes into the ditches, it goes all the way down the water, and then that ends up the water that we drink. We want to make sure that we're also good into these triple E's: engineering, economic, and environmental benefits. So we do have 7 types of plastics. So it's not, when we say in daily life that's plastic, that's not as easy as it is. These can be classified into 7. We're very familiar, or we encounter on daily basis, typically type number 2 and type number 4. Then even you use some of that apparatus here or utensils to eat your lunch. So that's number 2 and number 4. We usually, and not all of them will be suitable for asphalt. We're expecting that not all of them are suitable for asphalt. So our job is to take every and each type and try to see how it can benefit asphalt or not. And if it does, how much it can benefit. Is it worth pursuing? What's the long-term implication of including these into our asphalt mixture? Because again, we want to make sure we have a good performing mix, we have longer lasting pavement. We're pushing for recycling, we're pushing for sustainability, but we want to make sure that we're maintaining the good performance. That's very important. So we're looking currently in our research, and I'm going to put a more practical video for you to watch in a second. We're looking at types of plastic to be used, laboratory performance, health and safety. When you put plastic through the plant, will it generate some fumes that are bad for you or the people who are the paving crew, who are doing the paving operation? Method of incorporating that, should you include it in the asphalt binder, what we call wet process? Should you include it throughout mixing, that what we call dry process? Plant operation, do we need new equipment or new technique or new practices at the plant to be able to produce that mix? The same thing for construction. I want to make sure that the people out there can lay down and place that mix in the correct manner that meets our spec, but they do not need maybe, do they need more training? Do they need, are they being subjected to emissions and fumes that are not good? So we're looking into all of that in some of the field trials that we are doing. So again, we're looking at repurposing the plastics. We're looking at maybe cutting down on some of the virgin material that we're using, whether asphalt binder or aggregate, then repurpose that and use it through plastics. So that helps us to save some of our source of material that we have. And at the end, also, we're trying to have a better understanding of the potential environmental benefits. So is it worth pursuing that route? And if it is, how much would that have implication in terms of environment-wise? So what you're going to see in the next video is some field trials that we've conducted in Richmond in 2021 and 2022. We looked at putting our typical feed-up mixes alongside some mixes that have recycled plastic. You'll see some of these operations at the plant as well. So we looked at it from design, paving operation, lab performance, and field performance. So it's some movie time. I'm gonna bring down this. Let me stop sharing. Do this. Share some. Like many other state highway agencies, the Virginia Department of Transportation is extensively working to determine how to best incorporate recycled materials such as recycled asphalt pavement, recycled crumb rubber, and crushed concretes into their roads. With the change in recycling streams over the past few years, the interest in diverting plastics from the waste stream for reuse in asphalt mixtures has been a growing topic for highway agencies. In 2017, plastics accounted for over 35.4 million tons of the waste in the United States, with only 3 million being recycled, around 5.6 being undergoing combustion, and around 27 million tons being stacked and landfilled. Hence, the current plastic waste challenge became a critical concern.
As much as we care about diverting plastics and any other material coming from various waste streams, we also care about including these materials in a very responsible manner that will guarantee good performance.
What's in it for Virginia? The initiative of including recycled plastic waste into asphalt mixtures has been on the agency's radar for years. This initiative promotes defining a sustainable solution for both improving the performance of asphalt pavements in Virginia and diverting the plastic waste from being landfilled and stacked and not being used as a commodity replacement for other raw material.
With over 57,000 lane miles of roads within the Commonwealth that VDOT's responsible for, this gives the department an opportunity to reuse and reduce the amount of waste plastics that are generated by the Commonwealth and globally as well. This opportunity gives us a good chance to become better stewards of the environment and provide a lasting, meaningful impact for the Commonwealth and for the traveling public.
So one of our favorable practices when designing these types of mixes is to base it around performance testing and not just volumetrics. So during the design process of working with plastic materials and other different recyclables, I can't say that we found many challenges compared to what we already normally do. A lot of the processes, it's just about maintaining your consistency and just continuously, following the procedures as they're written in the spec.
The mix, as far as plastic goes, it's introduced through a fiber machine. It's blown into the plant up through the wrap collar where it hits the wrap, it hits the superheated aggregates, melts the plastic. The binder is introduced where it's mixed and then goes up the drag into the plant. We typically produce this between 325 and 340. And our lay down temperature is right around 300.
We saw these plastic trials as a win for everyone involved. We're taking the recycled products out of the landfills. We're not augmenting the plants too much, improving the quality of our asphalt overall. So we really saw this as a winning opportunity for everyone involved in this project. So that's why we were really happy to sponsor this in the Richmond area. In the field, this product did not require anything special. We just followed our normal paving practices. We received the routine densities we would typically see with any other product. No special training for everyone involved, no extra roller passes. Everything was like our status quo for this project. So it was really a beneficial product.
First, I want to say appreciate the opportunity for working with the Department and Research Council on these opportunities of recycling and sustainability. So anything that has to do with recycling and sustainability, we want to be part of it. And anything that we can do to help support recycling, we want to do that.
With the incorporation of recycled plastics into asphalt, of course, there's a concern that this material will begin to shed plastic particles into the environment with use and with age. VTRC and VDOT are currently working towards addressing this issue to determine if this is a true concern.
And by the way, you're the first group to formally watch this recently approved VDOT video.
Didn't know you were starring in it though.
So we talked a little bit about recycled plastic. So when we put plastic waste into asphalt, I don't want you to think that you can have a big, like garbage bag where you can stack all your, bottles, empty bottles of water, and then you just bring them to, my office and tell me, hey, Jhony, take them and put them in your asphalt. Doesn't work like that. So that plastic has to be washed, shredded, processed, has to be screened, something that's feasible and usable for asphalt, something that is not. And then you can see various types. For example, that's combination between type 2 and 4. You see it's a shredded. And once you look at it, you know that's a shredded plastic, but that's not just random plastic that we're collecting from the dumpster and then we're shredding. The second one is the type 1. That's a processed plastic. So we add some chemicals for it to make sure that it's going to melt when mixed with the asphalt. So that picture is from Old Stage Road down in Chesterfield area, the Richmond district. So you're going to see the P1 is an asphalt. Put an asphalt mix that's on the right hand. The P2 was put in another asphalt mix that was laid down on lane number 2. So you do not. Then while you're walking on these roads, you're going to see like bottle caps or lids. You're not going to see that, or it's going to smell like plastic. Unless I tell you it has plastics in it, you won't notice that. And then one thing to let you know that we're putting it at a very low percentage, 5% and 3% of the binder content, not the whole mix. So as of the mix, it's really less than 1% of the mix is plastic, but you're still helping. I mean, we cannot go and say, okay, we're going to put 10 or 15% of the whole mix to be plastic. That's a little bit beyond what we can do with us. Just to let you know some of the environmental impact with that trial each night. So that went for 4 nights. Each night we were able to save around 610,000 single-use plastic bags. If you notice right now, when you go for grocery shopping, you have to pay for your plastic bags if you choose to. Otherwise, you're going to use a cloth bag to get your groceries. So we're helping with that. So if you multiply that by 4, that's a lot. And that's only for one trial, 4 days. I'm going to tell you that's a low number. Yes, if we do it more and more, we'll increase that number. And we had an offset of around 10,300 kilograms of CO2. That's good. You all look to breathe the O2 and not the CO2. So it was a win-win for everybody. For sure, it's still in the development phase, not ready for implementation, but we're on the right track. So looking at, these are some of the pictures. So these are the fiber machines that we use to blow in the plastic. So you see that small bag in the top left corner picture that gives the plastic and that gets blown into the asphalt mixture. And then that's the asphalt mixture in the trunk. Looks like a regular asphalt, unless I tell you it has plastic in it. And that's being paved. That's during the paving operation. No changes in paving operation. Standard practice were followed. The paving crew was not subjected to any harmful fumes and so on. And again, at the bottom right, these are the plastics that were used in that trial. Again, I want to look at cracking. If we're going to go with the maybe solid, the blue one, we noticed that the plastic mix shows similar or better cracking performance compared to our control. That means that the engineering framework that we adopted to design and produce these mixes were useful and were helpful and put us on the right track. Last year in summer 2022, we had another 2 trials. We're going to talk about the first one down in Prince George County, where we combined, where we put another plastic that's P1, the 5%, but the third mix, we combined both. We pushed the recycling on the wrap, and then we introduced the plastic. So I thought the first half of the presentation was how to increase the use of wrap. So now we did the wrap and we did plastic. We were able to produce 2 beautiful mixes. They were laid down beautifully. They're doing awesome for the second year, especially with the winter that we had and all the rain. Looking at some of the performance data, you'll see that durability-wise, we had similar or better. I don't want to go into the numbers. I'm just giving some overview. And tracking performance, tolerance performance were way above the 70 that we're looking for. You'll see that your plastics are way better than compared to the control, similar or better, as well as running, which will never be an issue because that stiffens the material. And then we had another trial off of Route 60, if I'm not mistaken, on Dorset Road, where we use another type of plastics, P4, another plastic, P5. That's the mix being produced, and then we place them. So every in each trial highlights a certain type of the 7 type of plastic that I talked about at the beginning, just to make sure, so we can gain a gradual knowledge of which type of plastic will work, which one does not work, and which one is more beneficial or provide improvement, which one is worth pursuing, which one is not. That's a core. So the lower left picture of the plastic, unless I tell you it has a plastic you won't see, so don't expect to see like brands of water bottles and lids and things like that. So it doesn't work like that. Looking a little bit at the data again, in terms of durability and cracking, we had a similar or better performance. So some of lesson learned there is when we do the mix design, should we account as a plastic as a replacement for aggregate, or as a replacement for the binder, or as a third component to be taken into consideration at the plant? We learned that yes, these mixtures have to be produced hot because the melting temperature of the plastic is much higher than the asphalt mixture. We need to have a good calibration of the cleaning machine, so we make sure if we're applying 5% of plastic into that mix, it's 5% within the first ton being produced as well as the last ton being produced on the job. Again, plastic does not love cold nights; they love warm nights or warm weather, so we're going to keep that in mind. The good thing is we did not need to purchase any new equipment. We did not need to pursue any new training, either for us or for the paving crew. And again, we looked at the dry process. That's when you put it during mixing in the fiber process, or when you put it in the binder. They have pros and cons depending on what the contractor like and they would like to pursue. We're looking at the consistency of that mix because plastic is a variable material, and what is suitable if we pursue dry process or wet process. So a lot still to learn, but we wanted to share with you some of the thoughts of some of that ongoing project. Again, we're looking at to see if microplastics are an issue. My colleague Louis Lloyd mentioned that in his picture, because again, we're trying to push for recycling, making sure we have good performing pavement. But we don't want to end up having microplastics into the water. That's not good. We're looking also on other types of plastics. We're looking at the long-term performance of these mixes. We're looking at fumes and emissions because 5 or 8 years down the road, these sections that were built are going to be milled, and then they're going to be included into the RAP stockpile. Now that RAP going to go directly into another mix. Will that plastic going back through the plant into the asphalt generate fumes and emissions that are not good for a human being? So we're looking into that. That's another study that we're not going to talk about now, that will come out in the next couple of years. And then again, environmental impact. Is it worth pursuing that initiative or not? I know we're not going to solve the plastic pricing, but we're contributing like other people are doing in concrete and other domains. So with that, I'll leave you with my information. Should you have any question, or doesn't have to be technical, something that you're curious about, just email me. If you haven't been to Charlottesville, this is a cool picture of our downtown during the winter. Come visit us. Have a good historical sites. Then I'm happy to answer any question.
Thank you. Let's do a round of applause.
Thank you.
So I think if we take some questions from the audience in person, and then I'll turn to the remote audience, and we kind of alternate like that if there's some questions from the remote audience. But let's start with in person first of all.
Yes.
When you mixed in the plastic and it melted down, is there any concerns with the effect of how that incorporates into the mix with the long-term maintenance of the plants or long-term maintenance of the paving machines? I mean, does the addition of the plastic, is that changing the consistency? And you know what I'm saying?
Yeah.
I mean, you've got certain material, chemicals you can use to clean the asphalt emulsion, and I'm not, you know, does it still work with the plastic included in the mix?
The answer is yes, it does work, but you bring up a very important concern because we don't want to make sure that these materials are suitable for the paving equipment that we do have.
Right.
Do not, degrade them at a faster rate than they're supposed to. So we check that, and it does not. But also there's something to be kept in mind that we're using 5% of the binder content. So you have less than 1% of your total mix. So it's a really tiny bit of plastic into the mix, which sometimes the coated pieces that have plastic do not even make the edge in the drum. So it wasn't a concern. But moving forward, if we push to 5% or 10% of the mix, then this is a very important point to be taken into consideration because, again, you want to push for recycling, but changing these equipment is very expensive and maintenance already costs a lot. So, but as of now, with the very tiny percentages, it's not an issue. But that doesn't mean it could not be in the future.
Well, I have a question or a statement.
Yes.
The by the way, I think this is all very positive, good stuff. Good class. A good thing that we're doing here at the Commonwealth. But the durability of the asphalt, how is it in comparison to the asphalt without the plastic elements? Durability, potholes, does it fall apart sooner, or is it a longer life? Do we have any?
So, yeah, I get your question. So at the moment, we're relying only on lab performance through the Cantabria test because these sites were paved in 2021 and 2022. So we do have 1, 2 to maximum 3 years of performance. As of now, we haven't seen potholes yet.
Good.
So I'm not sure if we're gonna see in the upcoming maybe years. You never know. But as of now, the field performance looks very promising. And we haven't seen anything that caught our eyes. We do visual inspection of each site every 6 months. So we haven't seen anything. So hopefully this will remain in the next couple more years. But you never know. Sometimes a big storm may flip some of these findings. So I hope this addressed your question.
So another question from the in-person audience?
Were there any like early indications as to which type of plastic would work best or be best suited for this?
So based on several factors to be taken into consideration, availability of plastic, price of plastic, as well as projected performance, type 2 and 4 are the best and most available to be most likely to be included in asphalt if we choose to go that route in the future. And that doesn't mean that every and each ton, every and each mix will have plastics, but it's one of the options. If we choose to pursue it, we'll pursue it. It's not. But type 2 and type 4 are the best candidate front runner at the moment. And these comes from polyethylene, from a lot of stuff that we use on a daily basis. So.
And then the remote audience, do you have a question?
C6 chat box.
Taryn will be checking the chat box.
Yes, and we did have a question just a bit ago. What percentage of the recycled plastic remains once it gets to the P1 state and then the P2 state?
Can you just repeat that quickly, Taryn?
Absolutely. What percentage of the recycled plastic remains once it gets to the P1 state and the P2 state?
I didn't get the question. Can the person maybe ask it?
So what percentage of the plastic remains after it's at the P1, P2 state? I don't know what the P1
Yeah, so the P1 and P2 state, P1 and P2 in my presentation were just type of plastics that that's nomenclature for plastics that we use, but they were used at 5% of the total binder content and 3% of the total binder content. So that's around 0.75% of the mix. We assume that we assume that once this is mixed with the asphalt, not necessarily all the plastic gonna be mixed, but all the plastic gonna go into the asphalt mixture and be placed. So I hope, so there's nothing of the plastic that remains outside. Maybe the question is how much is gonna be fully melted versus not fully melted. That's a different topic because we're still looking into that, and that's a very important, question and comment to be made.
So maybe whoever asked that question, if they want to do any follow-up, we can come back to that. I have a quick question for a person.
Sure.
So there's always a substitution effect. If you end up using plastics, it's instead of using some of the recycled asphalt. So does that have any downstream effects that now recycled asphalt is not being used as much because the plastic is taking place?
Actually, this is a very good comment. Recycled plastic will never replace recycled asphalt product, will replace the asphalt binder. That's a typical practice, and that's something we want because we gonna make it at the end of the road where we do not have crude oil and sources pumping, crude oil for us to be able to get asphalt binder. So this is more on the positive side of, cutting down a little bit on the asphalt binder. Asphalt binder is expensive. And then now you're using recycled plastic, so you can cut down a little bit, and then help doing recycling, again, engineered and good manner on the short term and the long term, then why not? So they will never replace the rail. In some cases, when you use recycled plastic, you cannot go high on the rail. So you have to limit to that. Then maybe this becomes a concern. But that's in limited situations. I see Nina has a question.
Yes, thank you very much on the presentation. I guess my follow-up question is, in comparison of the plastics, the recycled asphalt and standard or more traditional asphalt materials, do we have kind of cost figures or comparisons right now? Understanding that these are very early technologies and of course it costs more, but do we know kind of ranking what's more expensive or projected to be more expensive in the long term?
Very, very good but sensitive question. So at the end of the day, everything gonna be, converted to money, and that's very important. As of now, we do not have, so we cannot really judge if we're getting a more cost-effective mix versus not, because as you mentioned, it's a limited production, it's a newer technology. In some cases, for you to be able to pursue the job, you have to pay a little bit of money just to, offset the extra effort that has to be taken. It's a newer technology, it has a higher risk of failure and so on. But on the long term, the high wrap, for sure, it's expected to be cost effective because a bigger portion of your mix is being replaced. And we've seen some of the reports coming out of a big organization that have done similar research that there is a cost offset with that. So you're tackling the environmental benefit, you're getting, good engineered mix, but you're also getting an economic mix. For the plastic, it's too early to do that. For the high wrap, we can say yes, but the plastic is a little bit too early to do so. Actually, now we're doing kind of a life cycle assessment, life cycle cost analysis on that. Then hopefully in the next couple of years, we'll have a better judging. But anything new you do in the field these days is going to require more money regardless of, because you're changing the standard and people are spending more time, to do it the right way in the field.
Certainly. Thank you.
Thank you.
We have a few more online questions, a follow-up from the plastics question earlier. They said they were wondering what percentage remains of the original plastic once it's processed.
Oh, okay. So I'll give an example, actually. So for the case of the shredded plastic that has multicolor, that's 100% processed plastic. So there's nothing remaining. But the one that you saw, the crystalline, the white one, actually it's a 60% plastic, 40% non-plastic. So there is a portion of it non-plastic. There are chemicals to help, get it more homogenized with the asphalt. So in some cases it's 100%. In some cases you have maybe half of the plastic processed remaining. So now I understand the question.
Thank you so much. One more question from the online audience. What is the time frame for the environmental impact assessment for the recycled asphalt?
So we are getting the first outcome of that going to be end of October. And then with that, we're providing a step-by-step guidelines on how you can assess if your mix with recycled plastic will generate microplastics that are detriment and bad for the environment. That's number one. And then the second one, which attacks more the fumes and the emission, gonna come out early 2025 because we are visiting several plants. We're capturing some of these fumes. We're analyzing that. It requires a little bit more visits to the field, and then we try to do some. We're buying ourselves some time with a couple of paving seasons because our paving season, depending on the availability of the projects too. So we're getting there. We're seeing the light at the end of the tunnel.
We have a question from our in-person audience.
This is more of a big picture question, but are we the agency under any sort of time requirement, use of plastic, we're sending plastics in our mixed designs from the feds, from the HWA?
Not that I know of, we haven't been hit with any legislation about mandating the use of recycled plastic in the asphalt. The intent of trying these technologies, again, we do have a good performing mix in-house. We're trying always to improve and enhance any mix that we have on the list. We're just being ready in case it came, that we already have some of that background, and then we're gonna, reshape it towards the best of the agency in general. So again, we're not trying to change the standard practice. We're just exploring other tools that we'll have in the box. And when the time comes, they'll be ready. We have a good background. We've had good handle on it through field trials, and we're ready to hit the runaway running rather than maybe hopping. So
I think that's wise. It's only a matter of time, for sure.
that's the most and the best I can answer for such a question. I don't want to lose my job. I'm joking. I'm joking. But yeah, it's one of many other tools. I mean, that's not the only technology we're looking at. Looking at inclusion of hybrid rubber, we're looking at even inclusion of multiple other stuff like glass, crushed concrete, you name it. Just to have these tools, so whenever things comes to the table, we'll have them handy.
And this isn't directly related to what Jhony just said, but our lunch and learn in June was about fiber reinforced concrete, which you said was another example of a material using, some of which involves plastics and included in it for, I think, greater durability. And that was Chelik and Mary Sharifi at BGRC who did that. So if you want follow-ups with that, I mean, it's just another medium, obviously not the same as asphalt.
Yeah, we do a lot of fibers in asphalt as well. We didn't cover that. Just tell Chelik that asphalt is better than concrete. You will bring him for By the way, he's a legend and stuff, and I'm sure you guys will love that presentation too.
One last question. I mean, it probably doesn't affect the districts further to the east as much as it does the districts on the west. You mentioned it's not conducive to nighttime paving operations because of the polar ambient air temperatures. How does that factor into this? Because I know our paving industry here in the valley, they want to extend their paving season as long as they can. And obviously, if something like this goes against that and kind of shortens their paving season, then they're going to have issues with it on their end of it. So I know it's a negligible amount or a small amount of plastic going in there, but do you see it affecting much of the temperatures?
Yeah, actually,
requirements?
Yeah, actually it does. So how we came out with that conclusion when we had the trial back in 2021, it was towards the first week of October, and that week was really cold. It was night paving. We were around the 50-degree Fahrenheit. So we had some hurdles. It was still manageable to still produce the mix and get density requirement and so on. So that's why we said, if any job would have plastics in the future, so again, plastics are not on the list of bidded items. So contractors do not bid for the plastic. We're still in the research. So, but in case it makes it in the future, we do recommend that. Our recommendation is, regardless of the timing of the year, just pick kind of a relatively warmer, time frame to produce and place that mix, and then do anything else. So that will help them in scheduling and scheduling around the paving contracts as well. But again, the intention is not to change every and each mix to include plastic. So it's going to be maybe 1 or 2 contracts in the future. They can deal with it, in the middle. They don't have to push it over. So, but temperature is a key. Plastic will make your mix a little bit stiffer than if you have colder temperature. So you gotta look at it like you're trading an e-bond.
Yeah, I mean, we're already dealing with that on the SMA end of it. We're putting that down the interstate. We've got to do that during the warmest time of the year in the summer to get that done at night on the interstate. So, I mean, this would just kind of add to that if we went down that road.
Yeah. Because WMA additives won't work in this case. Like they will work on the wrap and the asphalt, but they won't work on plastics.
Okay, so it's getting just 1 o'clock. Any last questions in person? Any last questions online?
I like the idea of having lunch while listening to a nerdy person.
And our nerdy speaker didn't get his lunch, but I have yours. Well, thank you everyone for coming. The one in August will be in Fredericksburg if you do not feel like driving, or if you're remote and you feel like driving. But it will also be remote. Everybody's lunch and learn, which we'll be doing until January, will go in person and remote. And that topic is animal crash reduction and wildlife safety crossings. It's a kind of interesting topic. So I was on vacation last week and I drove under a weird bridge And I found out later it was wildlife crossing, that's the first one I'd seen in real life, and I was like, I'm gonna learn about that in August. Thank you so much, and thank you, Jhony, once again. Another round of applause.
I want to go down.